Hello ladies and gentlemen, my name is Ingus and I'm from IGS Electronics, and today we're going to be continuing with our S7-300 series PLC, and we're going to be jumping onto our next card. If you haven't seen already, we already covered the digital input data and output cards, well, at least the basics of it, and how to get them all going and addressing it within the TI portal. And today we're going to dive into analog cards. And analog cards, there's many different analog cards that Siemens sells, part of this family, but there's two of them that are very commonly used purely because they are very, I'd say, can be used with a lot of different signals. So from current to volts to resistance to temperature probes, and those two are SM311. There's actually two types of SM331s. So one of them is 1KF02, another one is 7KF02. The thing is that those cards are very, very similar to what they can do. It's just the 07, no, not 7, it's a 7KF. It's the one that's got like diagnostics. And boy, oh boy, they are very, very helpful. And if you do have an option to use, or, well, to use the 7KF, do so purely from diagnostics point of view, because it really, really narrows down that diagnostics part when things go wrong with your analog signals. And there are quite a few of them, and we need to cover each one of them in different videos because there's a lot to talk about, quite a few of them. Hopefully I'm going to be trying to get the message across as much as possible I can. We're going to be creating a basic, very dead basic. We're not going to be even doing norming or scaling and things like that. We're not going to do any of that. We're just going to use the basic move instructions to transfer the data, and so we can more or less read what is coming out of the data. And from there on, guys, it's a programming. That's a different aspect that needs to happen. So that's absolutely would have to be. Again, it very much depends on application and it's just the key is to understand how the analogs are working, how to wire them, how to identify them, and how to find them within a TI portal if you are struggling to find the faults, if there's a fault within your system, and just giving you a good idea of how to get yourself around it. Because remember, this channel is all about maintenance, so keeping your systems live and working, and something breaks down, somewhere you can come and have a look at it, possible problems you could possibly have to investigate. So yeah, that's what we're going to do today. So the first card we're going to be checking out today is the 1KF SM331 1KF01. So that's the first one we're going to be checking out today. So yes, and the first things we're going to be doing is going to be analog input with volts and milliamps. So yes, that's what we do today. All the related manuals and videos that I believe will benefit you in a possible way will be in the description below. Guys, do check out the manual in the description below. I'll leave with all the, it's a manual for the all the Siemens modules. You can look at all the wiring and explanations and things like that. Really good manual. Just if you just shift click Shift F or something like that, and you open your search and just type in your card and you'll find it for you. So definitely check that link out in the description below. So yeah, without further ado, let's get started. So before we get started, let's quickly go through the recap. What we've got in here is we've got whatever reason I just had the SF on my PLC. I don't know what that was all about, but that's gone. Oh, I must have moved the card out accidentally. So what we've got in here, we've got the integrated analog card in here, we've got a digital IO card in here. So plus we've got two analog cards in here. One of them is with diagnostics, which is a 7KF. And this one is a 1KF02. So that's the one we're going to be talking about today. So we're going to be working with voltage, and the one we're going to be wiring in is going to be our potentiometer. So which a lot of people like to have wiring potentiometers. So and at the same time, what we're going to be doing in here, we're going to drive in here, and the functionality we're going to be working on is we will take 10 volts from this guy in here, which is going to send the 10 volts to our potentiometer. Our potentiometer will be sending a variable voltage back to analog input 1. And analog input 1 will be receiving that signal and converting it and sending it back out. With the analog card we already wired in analog output in the last video, and that analog output will be sending the voltage to the drive, And at the same drive, as you can see, these two wires in here, this is my analog output. It will be sending the current back to the card into our next analog input in here. It's like a looping, so to give you a bit of understanding how the analogs would work. It's basically backwards, forwards, reading information from each other. So before we get started, as you can see, there's let me zoom it in. So hopefully you can see what we're looking at. Yeah, hopefully. Looks like we do. So as you can see in here, it says channel 0, 1, 2, 3, 4, 5, 6, and 7. So in all total, 8 channels. As you can see, there's got VA, millivolts, and resistance. So just because it's got these V on channel 0, channel 1, 8, and channel 3 millivolts, that does not mean that they are just for that, that can do just for that channel. Basically, it's this way of showing, Siemens way of showing to you which channels can be, what can be possibly done within this card. So this channel, the first channel, can do all of this. So it's all about all configurable inside to a portal. What signals is it supposed to read? So it's quite straightforward. So volts can be done in there, amps can be there, millivolts can be, and resistance can be done in there. So before we get started, I printed out a couple of examples in here. The ones we're going to be working on mainly at a voltage, and again, there is a 2-wire voltage input and the millivolts. There's a 4-wire, and also, as you can see down there, it gives us a nice illustration for potentiometer if you wish to do so. So that's exactly what we did in here. So the wiring is quite simple. So as you can see, you will stand for a volts, I will stand for the analog input, and S will stand for the resistance input. So it's pretty straightforward. If you're sending back milliamps, you will be going into the current. You will send your negative will be coming back here, and M0, and your positive will be going into the I plus. In our case, what we're going to be doing, we're going to be sending the volts. So we are actually going to send it into the minus. And here from the analog card, which is outputting R minus, which is a 10 volt source. So if you have the power supply and you're sending a 10 volts to your potentiometer here, that would be that power supply's negative. And obviously then it goes to the potentiometer and it comes out and it sends the variable signal via, this is basically via this guy into the, as you can see in here, you can see a reference, this guy in here. Reference comes through and it sends back into the volts. So the volts will be going here. You can have a 4-wire voltage output. Again, you can come in here and send in again volts in there, minus in there, plus in the minus. So quite straightforward. The current again, and when it comes down to resistance, we're going to look at that in the resistance a little bit more in the future. So that's pretty much what we're doing here, and this is pretty much just an illustration for the resistance in here. This manual is going to be description below, and also explanation for a current for this specific card. The 2-wire current and 2-wire current is a bit different than this card. So we're going to be checking that out differently. As you can see, and that 4-wire current is receiving the power, is going, and then it sends out minus goes to the M and plus goes to the I plus. Or if you are using 2-wire current, so the negative has to be supplied from the power supply that is supplying to your transducer, and then plus will go into your transducer through it and into the I plus. So we're going to be looking a bit more into that in the next video. We're going to be working with this card, so we're going to look at how that looks in more or less in real life. So when it comes down to a wiring in here, as you can see in here, my potentiometer is outputting a 2, which is my terminal 2. I'm not sure the thing is a terminal 2. So this is my return, which is going to be sending a 10 volts right back in here into my channel 1 in here. And at the same time, I'm using the 5th terminal. As you remember from the drawing, 5th terminal is my negative. And that negative as well is joining up with mana onto my analog output, because that analog output in here is set to 10 volts. So just give me permanent 10 volts to be able to work with potentiometer, because I don't have, at the moment, I don't have any other ways of getting 10 volts from anywhere. So I'm getting it from analog card. That's why analog card's negative is also coming in here. And also potentiometer's negative, as you can see in here, is going to a terminal 5 as well. And also, as you can see in here, I have a 4-wire current coming back. So from my drive, a minus and a plus, it goes minus goes in the 10 as per drawing, and but this time I'm using terminal 7, so 7, which is my current plus. As you can see, that so 7 would be on this channel in here, would mean that we are sending in channel 1, and it's standing for the I plus for our current. So that's pretty much our sort of circuitry we are using in here. So and yeah, and then obviously, as you remember from the last video, this guy right down here, and if you can see, that's sending 10 volts to our drive to a more or less well, control the right frequency. So let's jump on to the TI portal and get this configured. Here we are. So this is where we left off last time. So what we're gonna do in here, let's go on to our configuration file there. So I mean the actual PLC card view. I'll double click it. There you go. So the channels we're going to be working on. So first we need to create that permanent 10 volt. So let's take this guy in here. Let's put that in here. I'm gonna we're gonna name this one as a 10 V permanent out. So that would be for that one, and also we need a memory word to be able to do that. So we're gonna use a voltage. We're gonna give him a memory word. The next one available is 2. So let's go for that. So and change that to 2. So I haven't done that. So we've got that now. The next one, we are going to be outputting that into potentiometer, and potentiometer will be receiving an analog input 1, which is going to be this guy in here is going to be receiving potentiometer's voltage. So we're going to put that on in here, and we're going to call that one a potentiometer input. So and then the potentiometer is going to be outputting into the memory word. Again, this is very basic stuff, so no crazy program. It's just to give you some more of an understanding and ideas how this should be working. So that potentiometer, because it's an input, we need to send it into memory word so we can use it. So we can actually send it directly. I'll tell you one thing. Let's do with a memory word now. So potentiometer. Let's call it like that, and let's call that. We could actually send it directly, but let's go to memory word. So memory word, and that next one is 4. So having done that, so now that we are going to be receiving another input, which is going to be coming from drive, so telling us what is the actual speed it is, and we have actually, where do we wire it in? We wired in a second channel, yes. So, and we're going to call that a drive, and that drive will be sending that information into the drive. Well, let's just say, so we can have a look, read it as well. So and we're gonna call that, we're gonna send that into another memory word, and then you're gonna say memory word, and that's gonna be 8. So we can sort of read it. What is what? Is 8? No, that could be 6. It's not used. Let's go nice in sequence. So having done that, so let's go back into the main. So let's, again, everything's going to be just very basic programming, nothing literally fancy. And then go into move. And so we are going to, what we did in here, we're going to go for memory word. So we can just set that voltage. Output to a, give us a full 10 volts. So that for that one we need PQW. What do we have on the permanent out? 752. So here we go. Actually we could, here we go, we've done that. So let's get another network. So from there on, we're going to do another move instruction. So where are we? There we are. So we're going to be move. So from that, we need a read potentiometer's input. So this is going to be a PIW256, and we are going to send that actually into the memory word MW4. So memory 4, and at the same time what we're going to do, because this one there, remember, and I'm not sure you watched the last channel, this is the guy who was sending the voltage out to our drive. So now we want that potentiometer to send that voltage to the drive from so we're going to delete this. We don't no longer need it, and we are going to say you are receiving that reading from actual potentiometer. And also we want to have a look at it at the, where's the thing here? So what we are getting back from the drive. So, and that's going to be a where we go, PIW 258. Hopefully we didn't mess anything up in here. Well, if we do, we'll find out. And that we're just going to send into the reward in here. So this guy will tell us the drives, what drive's doing. That's going to be receiving the input from the drive, sending that into the output in here to send the speed out. So hopefully we got everything right. So only things left to do, I think, oh yeah, and then we need to go to make sure that our cards is configured to what we're trying to do. So let's go into this guy in here. Double click on that one. Let's go into properties. Come on, don't freeze on me now. Ooh, it did. I think I double clicked it too much. So, channel 0, yes, configured to voltage, input voltage 0 to 10 volts, and channel measurement for the drive is actually going to be 0 to 20 volts. That's what's going to be coming, 0 to 20 milliamps, sorry. It's coming back from the drive to give us actual speed as well. So that's all there. So, and yes, and that card has been set up to do voltage as well, yes. So what we're doing here, let's pump this in with all the what we just did. I know this video is dragging on, but I still give you the, let me know in the comments below if you're getting bored watching the programming part of it. So we are I can do this all off camera, but just in case you do want to see what I'm up to, might as well show it to you. So start up all the modules. So, and from there on, let's go into the actual what's it called, the monitoring. So right, let's see, let's make, how much did we mess anything up or not? So we should see things fluctuating. Come on. So let's go into the thingy. Again, this part in here is not necessary. It's already standard 2,000, 27,000, 27,000. Yeah, that's in here. It's just giving us a permanent 10 volts in it. It doesn't need it. If you are using external voltage, you don't need that. I'll just pulling out from my output card. So right, this is what we're seeing in here. So potentiometer input at the moment is standing at 27,000. Let's do the spinny bit. There we go, that's changing. So that's good. And as you can see, the drive is not receiving anything back. As you can see in here on the top, there's a bit of a delay. So the response is not that great, to be perfectly honest, from this potentiometer. I'm not sure why. I'll check out in the next video. Check out the other card. Maybe this response is better. So yeah, as you can see, everything's changing. So only thing we're got to do now. So it looks like all that is working, and I don't think we need to. Let's just start up the drive. Whatever reason, something's not working. I'm not sure what's not working. Oh, here we go, it was the wrong button. So as you can see down here, as you can see down there, this instruction drive is receiving information from the actual drive that that's its actual speed is doing. There it goes, the full speed, 10 volts going out to full 50 hertz. And there you go. So that's a couple of analogs. One is current, one is voltage, and you can literally read. I'm not sure you can really see it. This is what I'm playing with it. I'm actually gonna go in the live camera. I'm gonna show you now. So yeah, now we know everything's working well. So let's get back on the camera and have a look at it properly. Here we are. So let me just zoom it out. There's our motor. So there we go. So we slow down. As you can see, there's a bit of a delay. See? It does work very well. It's just I'll show you a bit more in there. So yeah, I'm not. There's definitely some delay. I need to check that out. What that is? Maybe it's to do with the card. It's processing the signal. But yeah, there we go. And that, ladies and gentlemen, will do. So you can see my drive is there doing his business. And that, let me just stop that. And that, ladies and gentlemen, will do for this video. This is where we're covering this card and sort of give you a bit more understanding what this card can do. I didn't show the about resistance and things like this. Are going to be different videos. We're going to be checking out thermocouples and things like that. So this today is just voltage and the potentiometer. If you do want to change wire in your potentiometer PLC, that's pretty much how you do with your analog card. Next video, we're going to be jumping on this card. This is quite a bit more extra fun. So we're going to check out as well the 2 and 4 wire current, how that works and how those transducers look like. So I got a couple in here, so one in here, and then we're going to be checking out the other products that I have. So yeah, that'll do, ladies and gentlemen. Hopefully you enjoyed the video and it is giving you a good ideas how things are working, and you're well on your way understanding how this process works. So yeah, so if you like the video, don't forget to smash that like, do subscribe if you like what we're doing here, and then you're new to the channel. Other than that, thank you very much for watching, and I'll see you in the next video.